All right. So in this video, we're going to go over some ionic compounds questions. So let's start with this question over here. So we have some ions. So let me take a picture so that I can write. Okay. All right. So we have sodium plus, magnesium 2 plus, and then we have fluorine, and then chlorine. Okay. So if you consider these ions, right, fluorine is over here, chlorine is over here, and then the sodium or plus, just sodium. Okay. Sodium and magnesium are in the same period as chlorine. Okay. So what is going to happen is, let's see. Now, if you think about sodium plus and magnesium 2 plus, they have 10 electrons each, right? So sodium is 11 when it is neutral. When it is plus, it's going to have 10 electrons. Magnesium has 12 electrons when it is neutral. When it is 2 plus, it's going to have 10 electrons. And then F minus, okay, is going to have 10 electrons as well, because fluorine has 9 protons. That means 9 electrons when it is neutral. Therefore, F minus should be 1 more electron than that, therefore 10 electrons. Okay. And then when it comes to the charge, okay, so or the number of protons. So if you write them down here, I'm going to write magnesium 2 plus and sodium plus and F minus. Okay, the number of electrons are 10, 10, and 10, but the number of protons, okay, you're going to have 12 protons in magnesium 2 plus, 11 in sodium plus, and then 9 in fluoride minus. Okay, because you have a larger number of protons in the magnesium 2 plus nucleus, the magnesium 2 plus magnesium nucleus is going to attract the electron cloud more strongly, making the electron cloud smaller. Okay, therefore magnesium 2 plus will be smaller than sodium plus, and then sodium plus will be smaller than fluoride minus, because we have a relatively lower positive charge in the fluoride nucleus compared to the other ones. Okay, you have more electrons than the number of protons there. And then you know that between fluoride minus and then Cl minus, okay, because they're in the same group, when you go down a group, you're going to increase in size because we are adding shells. So Cl minus has to be the largest. Okay, so Cl minus should be over here. So the correct order should be magnesium 2 plus, sodium plus, F minus, and Cl minus, which is option C. Okay, let's see if I can go back and enter that answer. All right, here we go. All right, question number 2. You're given a peg diagram, and then you are asked about which statement is true about the relative strengths of interactions in the dissolved state and the undissolved state. Okay. Now, again, I'm going to take a picture so that I can start writing on it. So here's my dissolved state, where we have ion-dipole interactions, and then here's my undissolved state, okay, UD, where we have mainly ion-ion interactions and then intermolecular forces in water. Anyway, so now, I mean, if we consider the potential energy, undissolved state has a lower potential energy. Okay, therefore, this is going to have, our undissolved state is going to have stronger interactions. Okay, and then what do we have in the undissolved state? Ion-ion interactions. So the ion-ion interactions in the undissolved state must be stronger than the ion dipole or ion water interactions in the dissolved state. All right, let's look at the choices we have. First choice, ion dipole interactions in undissolved. No, that is incorrect. In the undissolved state, we have ion interactions, not ion dipole interactions. Second option, ion dipole interactions in D, which is correct, are stronger. No, that is incorrect because the dissolved state has a higher potential energy, meaning you're going to have weaker interactions. Ion dipole interactions in D are weaker than the ion-ion interactions in the undissolved state. So that is correct. Just to complete this, let's read the last one as well. Ion dipole interactions in the undissolved state are again, undissolved state does not have ion dipole interactions, it has ion-ion interactions. So I'm going to stop reading beyond that. Okay, so the correct answer is option C. Okay, so let's enter that. And then let's move on to this question over here. You are given a chemical reaction and then you are asked to write the balanced chemical equation. All right, so when you're given the chemical reaction, it's much easier. All you had to do is you need to see that we have the lowest whole number ratio between the substances, between the molecules or the compounds in the substance, compounds in the reaction, and then also the number and types of atoms balance out. That is it. Okay. So first things first, if you think about the first option over here, it is incorrect because you have water, which is one of the reactants in the product side. Okay, you cannot have reactants on the product side or products on the reactant side in the balanced chemical equation. So that is out. And in the second one, it is not the smallest whole number ratio because you can see that everything can be divided by 2. 2 can be divided by 2, 12 can be divided by 2, 6 can be divided by 2, and 4 can be divided by 2. Therefore, this is not the smallest whole number ratio. Therefore, option 2 is out as well. If you look at the third option, we have things fine here. We have 3 calciums on the reactant side, okay, and then we have 3 on the product side, which is great. We have 2 phosphorus on the reactant side and 2 on the product side as well. Therefore, phosphorus are balanced. We have 12 hydrogen atoms on the reactant side, and we have 2 times 3, 6 plus 6. Because in pH3 we have 2 of them. That means we have 6 hydrogens coming from pH2, pH3 molecules, and then 6 hydrogen atoms coming from calcium hydroxide. Therefore, we have 12. That is correct as well. The last thing is oxygen. We have 6 oxygen atoms, and then 3 times 2 is going to be 6 on the product side as well. So everything is balanced. Okay, so the correct option must be option C. Let's look at the last option as well. Now, if you can look at this, we have 6 calcium atoms over here. We only have 3 over here. So therefore, this is not a balanced chemical equation. So that is out. So the correct answer is again option C. All right, determine the charge of titanium in titanium phosphide. Okay, so phosphorus is under nitrogen, right? Nitrogen phosphorus. So that is in the 5th group, okay, which is 3 groups away from the noble gases. Therefore, they're going to form -3 charge. So phosphorus is -3, and therefore, if we have only 1 titanium, okay, we know that anion side is -3. The cation side must be +3, so that we have a neutral compound. So because there's only 1 titanium ion, its charge must be +3. Therefore, the correct answer is option B. Right, let's go back and select +3 and next page. Right, question 5. Okay, let's take a picture. Okay. All right, which of the following submicroscopic representation best represents potassium phosphate? All right, here we need to know the charge of phosphate. Phosphate is 3-. Okay, and then we see that we have to have 3 potassium ions, so which is minus charge, okay, 3 of them to balance out the charge of phosphate. Okay, so the ratio between the cation to anion ratio must be 3 to 1, meaning for every one phosphate ion, we need to have 3 potassium ions. That's the idea there. Okay. Now anyway, so if you look at options B and C, they are out without even considering anything. The reason is B and C show molecular compounds with discrete molecules. We don't have molecules in ionic compounds, therefore those two are out. And then between options A and D, okay, so in A, for every one gray atom, you have 3 red particles. For every one gray ion, you have 3 red ions. Okay, so that's a match. Okay, so this is good. I'm going to go with that. But let's consider option D as well. So we have 3 gray ions and then 6 red ions, meaning for every one gray ion, we have only 2 red ions. Therefore, this is not a match. Okay, so here our red must be potassium, and then this gray must be phosphate, and then that's why A is the correct answer in question 5, for question 5. Okay, let's move on to question 6. Take a picture. All right, electrolyte solutions contain ions. Okay, so I mean, it doesn't matter what this name is, whether you know what this term mean, okay, but you are told that these solutions contain ions. Okay, and the question is, which of the following compounds will not create a good electrolyte solution? Okay, now if you consider all of these, calcium chloride is going to be an ionic compound. Why? Because you have a metal and non-metal. Barium chloride, barium is a metal, chloride is non-metal, therefore it's going to be ionic. Sodium chloride, so it's ionic, we already know that. Okay, but if you consider this molecule over here, this is actually ethanol, is a molecular compound. Okay, it's a molecular compound. Now the thing about the molecular compound is they don't have ions. Okay, so if they don't have ions, I mean you wouldn't expect them to dissociate in water to produce ions. Okay, only ionic compounds dissociate into individual ions, not molecular compounds. Okay, because this is a molecular compound, this would be the worst electrolyte. Okay, because it doesn't produce ions. Okay, so the correct answer is option D. So, okay, because we asked if we're not producing ions or not an ionic solution. Okay, let's move on to question 7. All right, so you're given a submicroscopic representation and identify the limiting reactant represented by the following submicroscopic representation of the initial state. You're given the initial state now. Okay, remember you can be given the final state as well, but you're given the initial state now, and then you asked to find the limiting reactant. Now, the first thing I would do is I would balance this chemical reaction. Okay, so you can see that we have 1 carbon on the reactant side, 1 on the product side, so that is good. And we have 2 sulfur atoms on the reactant side, only 1 on the product side. Therefore, I would multiply the number of sulfur by 2. Okay, and now we will look at the oxygen. We have only 2 on the reactant side, but we have 1, 2, 3. We have 4 from SO2, because we have 2 SO2 molecules, plus 2 from carbon dioxide, which is 6. Okay, therefore, to make us have 6 oxygen atoms on the reactant side as well, I would multiply the number of oxygen molecules by 3. Okay, so that is what we have. For what we see is for every 1 CS2, we need 3 oxygen molecules to react. That, okay, actually, give me a second. Okay, so For every one, we need 2 oxygens. Okay, now let's count. So this is what we need. Okay, this is what we need. And what we have is we have 2 CS2 molecules, plus we have 1, 2, 3, 4, 5, 6, 7 O2 molecules. Okay, because red particles must be O2 molecules. Anyway, now with 1 we need 3, with 2 we need 6. Okay, so we need 6, but we have 7. Okay, so with 2 we need 6. This is what we need. Actually, this is the stoichiometry. Okay, but we have 7. We have more than what we need. Okay, what we have, this is what we have. We have more oxygen molecules than we need. Therefore, oxygen cannot be limiting our reaction. Therefore, the limiting reactant must be the other guy, which is CS2. So we're going to go with that. And remember, the products can never be a limiting reactant. So SO2 and CO2 are out right away. Only reactant can be a limiting reactant. So just like the name implies. Okay, so the correct answer is option 1. All right, here's another one. Which statement best describes the differences in melting temperatures these 2 compounds? So let's see. Whenever we have to determine the relative melting temperatures, we should consider the ionic force. Okay, just to remind you, the ionic force is directly proportional to the charge product. That means the charge of the cation times the charge of the anion, and inversely proportional to the distance between the ions squared. Okay, so you have calcium in both cases. Calcium will always be +2. Okay, and then nitride is going to be -3. Oxygen will be -2. Okay, now for the charge product for calcium nitride is going to be 6. And so let me write that down. Calcium nitride, the charge product, or Q plus times Q minus, is going to be 6, while for calcium oxide, that is going to be 4. 2 times plus 2 times -2 is 4. -4. Its absolute value must be 4. So because you have a greater charge product in calcium nitride, I would expect calcium nitride to have a higher melting temperature. Okay, therefore option B is out and option D is out, because it shows that calcium nitride has a lower melting temperature, which cannot be. All right, and then between options A and B, we have to read them now. The strong ionic force due to greater charge product. That is absolutely correct. So this is the correct answer. Let's read the third one as well. Strong ionic force due to smaller distance between the ions. No, that is not the main factor. The main factor is the charge product. Okay, so you always look at the charge product first and then the size. So for that reason, this is out. Okay, so let's go with that. All right, question 9. Arrange the ionic species below from weakest to strongest ionic force. Again, ionic force is all about, oh, can't draw it. Should take another picture now. Okay, the ionic force is directly proportional to the charge product and inversely proportional to the distance between the ions squared. Okay, and then whenever you are given something like this, what I would do is I would write out the charged products. But we have lithium chloride and let's say magnesium sulfate, and then no, give me a second, let me erase that. Okay, so we have lithium fluoride and then we have calcium chloride, and then we have magnesium chloride, and then we have magnesium sulfate. Okay, so we first write them out, and then we are going to write the charge product. Okay, so the charge product is okay, doesn't write for some reason. Anyway, charge product is charge of the cation times the charge of the anion, the absolute value of that. That's what we need. Now, to do this, we'll write out our charges first. Lithium is always +1, chloride is -1, calcium is +2, chlorine is -1, magnesium is +2, fluoride is -1, and magnesium is +2. The sulfate ion, this entire thing is -2. So we have that. Now we just need to write the charge product. So for lithium chloride, it is 1 because 1 times 1 is 1. And for calcium chloride, it is 2 because +2 times -1 is -2. Absolute value of that is 2. And magnesium fluoride is the same thing. Okay, it's going to be 2. And magnesium sulfate, on the other hand, +2 times -2 is -4, but the absolute value is 4. Okay, so because we have greater charge product in magnesium sulfate, it's going to have the highest melting temperature, and then it's going to be least ionic force will be least or weakest in lithium chloride because it has the least charge product. Between calcium chloride and magnesium chloride, okay, so this is very easy to decide because calcium is a larger ion, okay, and then the magnesium. Okay, so this is magnesium. And then again, chlorine or chloride ion is a larger anion than fluorine. Okay, so as a result of that, so the distance between the ions in magnesium fluoride is going to be much less compared to the distance between the ions in calcium chloride. Okay, therefore you're going to have a weak ionic force in calcium chloride compared to magnesium fluoride. So therefore the order must be this. So the correct answer is option, I think it's 3. Yeah, let's go with 3. Okay, here we go. All right, question 10. The process of dissolution of a certain ionic compound is described by the following Peck diagram, which is the most likely identity of this compound. So here you go. The dissolved state is, let me see, the dissolved state is in the is favored by both potential energy and the number of configurations, because our dissolved state, which is over here, has a lower potential energy. Therefore potential energy favors the dissolved state, and also it is favored by the number of configurations because it has a higher number of configurations. Therefore this is going to be always soluble. Okay, but if you consider these ions given to us, right, barium is +2, sulfur is -2 based on the position in the periodic table, because barium is in the second column, second group, of its +2. Sulfur is 2 groups away from noble acid, of its -2. Therefore the charge product here is let's say the charge product for barium sulfate is 4. Okay, the mantra is if the charge product is equal or greater than 4, it's going to be insoluble. Therefore it's going to be insoluble. Okay, zinc sulfate, the same thing. Sulfur is -2, therefore zinc has to be +2. The charge product is 4, therefore it's going to be insoluble. Potassium chloride, potassium is +1, chlorine is -1. The charge product is 1. Okay, this is going to be soluble always. So let's say soluble. Okay, and aluminum sulfide, aluminum is always +3 and sulfur is always -2. Therefore the charge product is 6 for aluminum sulfide, therefore it's gonna be insoluble. The only soluble compound here is potassium chloride, therefore this must be for potassium chloride. That should be my correct answer. Okay, so I go here and select potassium chloride and hit next. Okay, here's another compound. You're given potassium carbonate is commonly used in production of soap. What is the most likely formula of manganese 2 carbonate? Okay, so again, manganese. So we know carbonate is gonna form 2 minus ions, all right? And then if manganese 2 is given, that means manganese should have +2 charge. To neutralize 1 carbonate ion, you just need 1 magnesium ion. Therefore, manganese ion, Mn2 plus. Therefore, the correct chemical formula must be MnCO3. Option D. All right, which of the following compounds do you expect not to dissociate in water producing hydroxide ions? Okay, then again, okay, do not get bogged down by what ions don't dissociate. Okay, so here's the thing. All right, if you look at these compounds, you can see that potassium hydroxide is an ionic compound, and calcium hydroxide is also an ionic compound because you have metals and nonmetals. Okay, and then when it comes to this compound over here, it's going to be hands down molecular compound. Okay, so now because calcium hydroxide and potassium hydroxide are ionic compounds, they're going to dissociate in water into individual ions, producing so in calcium hydroxide case, calcium 2 plus and OH minus ions. Okay, in potassium hydroxide, it's going to produce K plus AQ and OH minus AQ ions. Okay, but the thing is, when it comes to molecular compounds, it's not going to dissociate like that. Just ethanol, it's not going to dissociate. It's going to just interact with water. Okay, so the correct answer here is the molecular compound. The only molecular compound that is not going to dissociate in water will be your answer, because it doesn't have any ions. Okay, I mean, as it is, it doesn't have ions. Therefore, it won't produce any ions. So it produce OH minus ions and dissociate in water like that. Okay, so that's it. Let's see how we did. I'm going to go ahead and submit the quiz. There you go. I got 100%. Okay, so I hope this helped review some of these questions from mainly ionic compounds, and then there were 2 questions from some basic chemical reactions as well. I'll see you guys in class. Bye, everybody.